A uniform rod AB of mass capital M and length 2a is as shown on the diagram, and it has an end A on rough horizontal ground. Okay, so just indicate that. And then it's also resting on a horizontal peg. Now, because we're told this distance is 1.5a, that must be 0.5a. And then we've got an angle alpha to the ground where tan alpha is 4/3. In this past paper, we've had a lot, actually, this is the third one where we've had an angle in terms of tan and a fraction. So we've got 4/3 here. This will become 3, 4, 5 triangles. Sine theta will be 4/5, and cos theta will be 3/5. And the magnitude of the normal reaction of the peg on the rod at C is S. Well, let me get all of the forces drawn. So there's going to be a weight acting in the middle because remember we're told it's uniform. And this will be mg, capital mg. Just going to draw a dotted line in here. That angle will be theta. And as I said, it's halfway along, so it's going to be A here and A continued up to B. Any other forces? Well, we're told that the normal reaction at C is equal to S, so it's going to be going perpendicularly to the rod from using the peg, and that is going to be S. And then there's also going to be a normal reaction from the ground, which I will call R, capital R, A. And then finally, we are told that there's rough ground, so there's going to be a frictional force. It's got to be acting this way. And the reason I know this is that because S is acting partially to the left, there's no other forces horizontally, it must be acting to the right. Otherwise, it would slip down. So that is going to be capital F, A. Okay, good. Now we're asked to show that S, the normal reaction from the peg, is 2/5 times mg. Now, typically in this sort of question, we're going to take moments, and then at some point we're going to also resolve forces. But moments are always a good way to start because you can just get rid of forces straight away. So I'm going to take moments about A because it just gets rid of RA and FA straight away. Take moments about A. So then we've got the perpendicular of the force times the distance from each one. For S, I'm going to get, okay, I'm going to look at S. That is going to be an anti-clockwise moment. It's going to be S multiplied by 1.5A. And that must equal the component from the weights. That's the only other force I need to think about because RA and FA are a distance of 0 away from A, so we can ignore them. So it will be equal capital mg cos theta multiplied through by A. The A's cancel, and the cos theta, as we had before, is 3/5. So that means I'll write it as 3/2s is going to equal 3/5 capital mg. And we can rearrange that. We can divide through by 3 times through by 2. S is going to be 2/5 capital mg. Now for the resolving forces part. So we're told that the coefficient of friction between the rod and the ground is mu, and it's in limiting equilibrium. So it's on the point of moving, which means that the frictional force will equal mu times the normal reaction at A. It's not less than or equal to because it's actually on the point of moving. So we've just got to work out FA and RA. And this is where the resolving forces comes in. So I'm going to resolve, I'm going to resolve vertically. Then I'll get a vertical component from S. Now, if I draw a line here, that will also be theta. I have to kind of figure out why that is. One way to do that is I could draw a horizontal line, and then these two would be Z angles, so that would be theta, and then these two add to 90, but then so do these two. That is why that vertical is also theta. Hopefully that made sense. So that means S cos theta, that's going to be the vertical force. So I can say that 2/5 mg. Wait, I'm going to substitute in for it in a second. Let's just write down s cos theta, and that is simply going to, or it's going to equal, oh, sorry, plus RA, because I've got that force going up as well. That is going to equal capital mg. So that means 3/5 times 2/5 capital mg plus RA is equal to capital mg. That is 6/25, so RA is going to be 25/25 minus 6/25, 19/25 mg. Then let's look horizontally. In fact, probably should have done that one first because it's a little bit nicer. It must be that FA acting to the right is equal to SA sine theta. I haven't really talked a lot about actually resolving here. I've kind of just assumed that you're happy resolving forces. But remember, this one here is the opposite to the angle. That's why I'm using sine. Whereas before I had cos because it was adjacent to it was like right next to the angle. Okay, so I've got S sine theta equal to FA. So that'll be 4/5 times 2/5 mg, which becomes 8/25 capital mg. And we're one step away. Mu is going to equal FA over RA. So it's 8/25 capital mg over 19/25 capital mg. These just cancel. The 25s cancel. We're left with 8/19. That's our exact value. It's probably worth putting it in your calculator because remember, this is a model. So work it out to three significant figures. 8/19 is 0.421. Yeah, I've just realized in this whole paper, I kind of was using sine and cos really quickly, not really explaining why we're taking cos and sine. But the thing is, if you're not happy with it, it's something to practice in isolation, not just in there's so much going on in these kind of questions. I've assumed that you're sorted with that bit. If not, then look back at I've made many other videos where I go for it in loads more detail. But if I just want to say where this mg cos theta went from, what I'm actually doing is drawing a little triangle here, and I'm splitting mg. So I've got a component going perpendicular to the plane and a component going parallel to the plane. And I wanted the component that was perpendicular to the plane. And if I call that, say, question mark, then I could write down that cos theta is equal to that adjacent question mark over mg, which is the hypotenuse. And we just rearrange that to get question mark as mg cos theta. And over time, you just learn when you're going from the hypotenuse to one of the shorter sides, you'd either use cos or sine. And here, because it's the adjacent, that's why I'm going with cos. Whereas if I wanted that bit there, which I don't use at any point, that would be sine. Okay, anyway, enough on that, but we're there with this problem. Well done.